Welcome to Carlton's Math Corner. Today we're going to continue our study on proportional and non-proportional relationships. At this time, please make sure that you have a math journal, your vocab packet, as well as something to write with. Today our target is I can determine if a table is proportional or non-proportional. First of all, we've only looked at graphs to see if they're proportional or not, and in the last video we talked about two criteria that a proportional relationship needs to have. The first thing is they need to both have a constant rate of change, and so basically needs to have a slope that is constantly running and rising the same throughout the entire line, or in this case, table. And then the last thing is that both sets of data has to start at 0. Okay? And so looking at this, is there possibly a table that shows a proportional relationship? Well, here's what I want to notice, okay? I notice right off the bat that, here's my x and my y coordinates and my x and my y coordinates. If I start subtracting them, so if I do 6 minus 3 is 3, 12 minus 6 is 6, and 14 minus 12 is 2. There really isn't a constant change here. This is 2. 4 minus 2 is 2. 8 minus 4 is 4. 12 minus 8 is 4. So if I take, rise, this would be my rise. Remember, y coordinates have to do with how much your line is rising, over my run, which is the x coordinates. If I take that and I take 3 over 2 and then 6 over 4, which actually 6 over 4 simplifies down to 3 over 2, so that's the same. And then over here, though, we would have 2 over 4, which simplifies down to 1/2, or 1 over 2. I notice that the slopes are not the same. That means this line would not constantly increase. That means it's not a perfectly straight line. Okay, and that is one of the criterias to be a proportional graph, is to make sure that you have a constant rate of change. Well, over here, let's check this one out. If I subtract the y's, we have 9 minus 6 is 3. 12 minus 9 is 3. 15 minus 12 is 3. 18 minus 15 is 3. And over on this side, subtract, we have 3 again. Actually, I guess this whole side is 3 as well. The difference is 3 between everything. So that means if I do my rise over run, rise on this side, so 3 divided by 3 is 1. And these are all 3 divided by 3, 3 divided by 3, 3 divided by 3. So that is my slope. So that means it passes the first criterion, the fact that my slope is 1, and I could put an x next to it. But now I need to see, will my line cross at 0? 0, 0. Well, remember both sets of data, so meaning both the x coordinates and the y coordinates have to start at 0, 0. Does this start at 0, 0? No, this actually starts at 0, 6. So that means that this actually has a y-intercept of, 6. I meant to say 6 right there. So this doesn't fit the criteria. Remember, we need to be able to fit both criteria. So Actually, I mean, this one was so close, it fit one of them, but then it didn't fit the other one. And this one was not close at all, this one. Okay, so let's look at another problem. Okay, so here's another table, and I want you to notice why this one's proportional. Can you take a guess why? Why is this one proportional? Well, first of all, I want you to notice that if you take, let's just say you take the first two ordered pairs, and we look at this and we subtract them. So if we subtract the y's, we have 6 minus 3 is 3, and 4 minus 2 is 2. And remember, y's are rise and run. So rise over run, 3 over 2. 3 halves, isn't that the same as 1.5? And if you take that, does that work for each of the problems? If you take 4 times 1.5, does that work? Let's try it. 4 times 1.5, it works. How about 8 times 1.5? Oops, 12. So it works. And 12 times 1.5 is 18. So it does work. So there is a common rate of change in this one. Okay, so there's a common pattern, and that is multiplying by 1.5. So that's the first part, that it works. Now the second part, if we keep this pattern going, if we keep going by 3's and by 2's, then that means if I subtract 2 from this 2, 2 minus 2 is 0, and 3 minus 3 is 0. So that means when I am at 0, on the x-axis, then that means that I am also at 0 on the y-axis. And that is the second criteria to make something proportional. So this table right here actually fits the criteria for a proportional relationship. And remember, the one below, this was actually the table that we did just a slide before. This one almost passed. Oh, so close. It had a common rate of change, but it did not cross at 0, 0. It actually crossed at 0, 6. And so this one is an example of non-proportional. Okay, proportional, non-proportional. If you would graph these on a graph, you would find that both of them have a straight line, but this one right here would cross at 0, 6, and this one right here would cross at 0, 0. And that's the main difference between the two of them. They both have a straight line, so they both have a constant rate of change, but one crosses at 0, 0, and that's proportional. The other one does not. Okay? What I would like you to do is I want you to try these 3 tables. And you're welcome to just see if you can figure out the slope and then see if they cross at 0, 0. Or, I mean, you could take a piece of graph paper and graph the ordered pairs and see, first of all, does it make a straight line? Because it needs to have a constant rate of change. And then second of all, see if it crosses at 0, 0. Okay. The other thing that we're looking for is, do you notice that every graph, no matter which one we have worked with in the past or anything, always had a number for slope that was positive. All of our lines were going up to the right, because a proportional graph, when we subtract and find the slope, we should get a positive number that's greater than 0. That's what we're looking for. If you come across right here, if you start subtracting some of these numbers and then you divide to find the slope, and you find that the rise over run is negative, then that does not fit the criteria either. Okay, so keep that in mind. We're looking for numbers that are greater than 0 for slope, and then so it's a constant rate of change, and then we're looking for, where it crosses the y-axis. It needs to cross at 0, 0. Okay, so try these 3 problems out. Thank you so much for joining me at Carlton's Math Corner, and I look forward to meeting with you again.